the mental approach is important. And so, with that, first of all, who does what I just described as routine planing with their lathe? Most people? Anybody? Nobody wants to volunteer for anything? All this is, well, maybe we can get the camera to see this. There's Rocky. Oh, two more tools. I asked Rocky to do this. He has tools I don't have. This is the spindle master that I was telling you about. It's a a shallow arc on the bottom, flat on the top, sort of a fingernail grind. It does work as my original did. Now this is the kind of a skew that has an oval cross section. It's not a flat bar of steel. And for the planing cut, this is what it was pretty much invented for. Is when you're in a planing position, you're tilted just a little. And so the thought was, if you have this sort of slightly rounded tool, it makes it a lot easier to roll on the rest rather than pivoting it on a rounded corner on the bottom. And so there is validity in the design of this. The compromise is it tends to be less than proficient at some of the other things that I do with this. But if you want to do good planing and you want to have one of these, good. It's a good machine. Now, this is not a bad example of a block that was just roughed out, rough turned. But you can see it's not as smooth, I think, as the ones that went around. And so the idea is this is a tool you can use
I had a silly question, Gary. Did you already find the centers on those? On that particular dowel stuff?
I did, because I turned it rough round. They were square. Yeah, the centers are marked, both ends there from the previous turning. Actually, for this, I think I'll just go with my glasses. I always wear something to protect my eyes. And if I was roughing and splinters are coming off, it really bothers me to have stuff hitting me in the face. And so I think it's a safety thing to wear a shield, not just for getting hit, but also for something to hit me and cause me to jump and do something else. Yeah?
Is your tool rest set right in the middle? Looks like
I don't know. My index actually is different than where the tool rest is. What I want to do is set the tool rest wherever it takes it to get the tool where I want it. The edge presentation on it. And so it's a bit there. But you'll see below center, above center. What I want is to cut on somewhere from here down. Now there's nothing theory wrong with cutting up here, but if you let that sharp tip get into your rotating 2U wood, there's a high probability you'll have an immediate catastrophe. It'll dig in and bad things will happen. And so it's just a better sweet spot to stay from the top quarter down, and typically I cut in the bottom half. Even though this was turned on the same lathe just this morning and used the same centers, when you rechuck it, you're off a little bit. The moral of the story is, if you don't have to rechuck, don't. So how do you present it? I present it so that the back of the tool is rubbing I always have something on the tool rest to guide me. Back of the tool is rubbing, and I just rotate in until I start taking a light shaving. Whoops, I forgot to bring a wedge. And that's all there is to a planing cut.
Now, you say the back of the tool is rubbing. Are you talking the back of the bevel or just the back of the tool?
This bevel right here rubs first. That's what you were hearing. And then I tilt it so that the edge just lightly comes in to cut. So we're talking RPMs. That's wide open in speed 2 on this lathe. Now, other things are, what angle do you want to be at? You can be pretty much like this. You can be extremely like this. Another curiosity is, how do you know how fast to go? And the interesting thing is, I don't really pay attention to how fast I'm going. When I'm cutting, I'll do one. I think we'll see if Steve can get it here. I'll do sort of a heavy cut. You just leave it there. There's a ledge there, and so when you have your skew this way, it cuts faster. This way, not fast. But all I do is maintain the amount of pressure it takes. To keep the edge riding along that bevel, or that shoulder there. And so that's that for a planing cut. Now, what can go wrong? If you get that edge in there like that, immediate catastrophe. If you roll it too far in like this, the wood will take control of the leverage, and you'll cut threads down the end of here and bounce off the tailstock before you can blink. It's just instantaneous. And so the thing is that, you know, it's a finesse thing. Don't try to take much wood, and that won't happen. You don't have to push hard on this. I was thinking if analogy of how much force is involved, and I think probably the best I can describe is it's like spreading room temperature butter on a hot muffin. You're moving the tool, but there's no resistance much there. It's a real light feel of finding that shelf. And so that's a planing cut. Everybody get to see the examples I passed around? So the first two were relatively smooth surfaces, not a whole lot of sanding needed, and that's the whole idea of this. This isn't intended to take off a lot of wood. The other thing perhaps I should mention is I find that for a planing cut, whenever you can have room for access, that I prefer a bigger, heavier tool. Bigger gives you more sweet spot, stay away from the point, and a heavier tool, when you get a little vibration, it tends to dampen it out some. It smooths it out. So, Planing cut, V cut. Here, we're just gonna make a V. Why do you wanna make a V? Well, a few things, but they're decorative all by themselves. They're a way to start other things. Now, V cut is sort of counterintuitive. You'd think you just sort of go in. You don't. You start with the tool high, and you just arc it in, like that. And one of the V cuts, on the V cut example, one of them was just that, a one slice, and that was it. You want to go deeper, you sort of go from both sides using just the tip and just arc it in. And try not to take off a whole lot of wood. And that's the magic of a V-cut. By themselves they can be decorative. They can be part of any other kind of coves and beads that you want. And in fact, for some beads, that's how you start if you want them to end next to another convex surface. Okay, peeling. We'll say now we're going to do a tenon down here. So this is a regular parting tool. You get down to the diameter you want. Now you could take your parting tool and go jab, jab, jab. Norm Abrams calls that nibbling on his table saw when he's doing it for something. But, you in good focus?
Yep.
A whole lot quicker than using the parting tool. And again, it's not a matter of you stick it straight in and scrape it off. It's like peeling an onion. You're high up on it like this, and you just arc it in. And all you want to do is keep it, just one onion skin per revolution. You saw the kind of shavings that came off there. They were big, wide peelings. Okay, shoulder cut. This is a derivation of, does the camera show rough shoulder there? Pretty good. So this is like a V cut, only you turn and a lot of times the tear out is so bad you have to do a couple. And then you have a surface that's much improved from what you had before. And it's really hard to sand a shoulder surface. Again, the ones I passed around, the hardwood one in particular, and the softwood one that was cut with a shoulder cut, is very noticeably smoother and probably better than you could sand it at that stage.